Okay, grade 9, here is your reviewer in trigonometry. With respect to the given angle, what is the ratio of the hypotenuse to the opposite side? So, if we recall the trigonometric ratios, the 6 trigonometric ratio involving right triangle, then we can have sine, the ratio of opposite side over the hypotenuse, the cosine, the ratio of adjacent side over the hypotenuse, and the tangent, the ratio of opposite side over the adjacent side. So these first three trigonometric ratios are the primary trigonometric ratios, and these last three here are the secondary trigonometric ratios because they are just the inverses of the first three. I put them side by side to show that they are inverses. So this tangent here is the inverse of cotangent because cotangent is adjacent side over the opposite side. The inverse of cosine is secant. As cosine is adjacent over hypotenuse, so secant is hypotenuse over the adjacent side. And sine is the inverse of cosecant. As sine is opposite side over hypotenuse and cosecant is the hypotenuse over the adjacent side. So there is a mnemonics or a technique in memorizing the first three trigonometric ratios, and we call it SO, which stands for sine, opposite over hypotenuse, ka, which stands for cosine, adjacent over hypotenuse, and TOA, which is tangent opposite over adjacent. SOCA, TOA. So going back to our question, what is the ratio of the hypotenuse to the opposite side? So we have this hypotenuse over opposite side is cosecant. So letter D is the answer. Given the triangle at the right, figure 1, set up the formula to solve the hypotenuse. So at the figure, from the angle 32 degrees here, so the 24 as the length of this side is opposite with respect to 32-degree angle, while x is the hypotenuse. So using the trigonometric ratio, which involves opposite over hypotenuse, it's the sine. So if we set up the equation, we have sine 32 degrees equals the opposite side over the hypotenuse. And using the sides, we have sine 32 degrees equals 24 over x. So that's the equation to solve for the hypotenuse x. What is the relationship between the hypotenuse and the shortest leg in the 30, 60, 90 triangle? Before we identify the relationship between the hypotenuse and the shortest leg, let us first deduce the relationship of the sides of the 30, 60, 90 triangle. First, let us draw an equiangular triangle. So if it is an equiangular triangle, it follows that all the angles are having a measure of 60 degrees. And it also follows that all of its sides are equal. So it's an equilateral triangle. Let us assume that all of its sides have measures of 2. Then let us drop an altitude from one of the vertices down to one of the sides. So in this case, here is the side where our altitude is being dropped from here down. Now, we notice that we have formed two right triangles. Okay, let us assume also that the altitude is to be labeled with h, which stands for height. So the base or the side where our altitude is being dropped is divided into two. So each part is 1 and the other part is also 1. So this is a right triangle, and by applying a Pythagorean theorem, we are going to solve for h. So Pythagorean theorem states that a squared plus b squared equals c squared, taking 1 as the a, so 1 squared, and taking h as b, so it's b squared equals 2 squared, the hypotenuse, which came from here. Then manipulating the equation, we have h squared equals 4 minus 1, which is simplified into h squared equals 3, because 4 minus 1 is equal to 3. And applying the cancellation method by extracting the square root of h squared, we also extract the square root of the other side, the square root of 3. But we know that the inverse of square is square root, so square root and square cancel each other out. So we have h equals square root of 3. Going back to the right triangle, we have 30 degrees if 60 degrees is divided into halves, and the other angle 60 degrees, and the right angle is 90 degrees. Notice the relationship between the sides of this right triangle. Okay, the opposite of 30 degrees becomes 1. The opposite of 90 degrees, which is the hypotenuse, is originally 2 from our original equilateral triangle, which becomes now the hypotenuse of this right triangle. And the opposite of 60 degrees is now square root of 3. So if you have a shortest leg of, say, 1 here, the hypotenuse becomes 2, and the longer leg becomes 1 square root of 3. So the relationship is that the hypotenuse is twice the shortest leg. The hypotenuse becomes 2 times the shortest leg based on our deduction here. In 30, 60, 90 triangle, what side is the opposite of the smallest angle? So in 30, 60, 90 triangle, naturally 30 degrees is the smallest angle, so its opposite side is this side, and it is called the shortest leg. So the opposite of the smallest angle is the shortest leg. While the opposite of 90 degrees here is the 90 degrees, we may not write it anymore, is always the hypotenuse. While the opposite of the middle angle, which is 60 degrees, is always called the longer leg here. It's the longer leg. If the right triangle has two sides congruent, then the two angles are also congruent. What special triangle is it? So the uh, two sides which are congruent are these sides, which are opposite to the 45 degree angle, and the largest angle is 90 degrees. That's why it is called right triangle. So it is called an isosceles right triangle. or 45, 45, 90 triangle. In 30, 60, 90 triangle, the hypotenuse is 48. What is the length of the shortest leg? So since the shortest leg will be half of the hypotenuse, or vice versa, the hypotenuse is twice of the shortest leg, and the hypotenuse is 48, what should be the number that if you make it twice is 48? So the answer in that question will be the shortest leg here. So that number that if you make it twice becomes 48 is 24. So the length of the shortest leg is 24. The hypotenuse of a 45, 45, 90 triangle is 4 square root of 2. What is the length of its legs? Before we answer that, let us illustrate here the relationship between the legs, which are congruent, and the hypotenuse. As you can see, if you multiply a leg by a factor square root of 2, then it becomes the hypotenuse of the isosceles right triangle, or the 45, 45, 90 triangle. So therefore, in the triangle that has a hypotenuse of, or in a 45, 45, 90 triangle that has a hypotenuse of 4 square root of 2, then since 2 is the factor that we multiply to the leg of this isosceles right triangle, so that it becomes the hypotenuse, therefore it follows that 4 from here is the leg of the isosceles right triangle. So the length of its legs is 4.